back, Honors Chemistry students, and today we are going to learn how to take a percent composition and change it into the empirical formula. You have to remember that this is based on the stoichiometric law of the law of definite composition, where every compound has its own composition by mass, which is linked to its empirical formula. You also need to remember the definition of an empirical formula. The definition is it's the simplest whole number ratio. For example, if I'm dealing with NaCl, its whole number ratio is 1. It's the simplest one. Fe2O3, it's a 2 to 3 ratio. Again, it's the simplest whole number ratio. So we're using the law of definite composition and we're trying to find the empirical formula when we know the percent composition. There is a link to the real world for this application. This is how forensic scientists identify unknown powders left at crime scenes. It's if I had an accident in the laboratory and the labels fell off of jars, how I would be able to identify any white powder. It's also used for inks, and it's also used for drugs. So let's pretend that we have a white powder and we do not know what its composition is. We then will take it to the lab and they will use a combustion experiment and it will provide this data. 27% of the compound is sodium by mass, 1.2% is hydrogen, 14.8% is carbon, and 57% is oxygen. Now, no matter how large or small our sample size is, that proportion remains constant, those percentages. So I'm going to assume I have 100 grams. When I do that, then my percentages automatically become grams. If it was 27% of 100, it's now 27 grams. 1.2% of 100, 1.2 grams. Now, a formula is based on proportion by moles. 1 atom to 1 atom of chlorine, 1 mole to 1 mole of chlorine. 2 atoms to 3 atoms for iron to oxygen, 2 moles to 3 moles. So I need to get this to moles, and we know how to do that already. We divide each one by their respective molar mass. And when we do that, we get 1.2 moles for sodium, hydrogen, and carbon, and 3.6 for oxygen. But that is not the simplest whole number ratio. So first of all, step 1, drop off percents, put in grams. Step 2, divide each by their respective atomic mass. Step 3, now we're going to divide each of these by the smallest value. 3 of them are equivalent to 1.2, the other is 3.6. What that gives us is a 1 to 1 to 1 to 3 ratio. Those numbers then become our subscripts. And our mystery powder is nothing more than baking soda, sodium hydrogen carbonate. Again, this works out when we have whole number integers. Check out the second video in this series to determine what to do when you get fractions in your lowest whole number ratio. Until next time,